Okay. Um, Welcome back to our technical interview preparation program. I hope you are doing great. In today's lecture, we are going to look at a very fundamental but very useful um, algorithm topic. It's called two pointers. Two pointers for arrays. We will look at three um, programming interview questions on LeetCode that will require this technique. But before that, I want to first spend some time to quickly review what we covered last lecture and also go through the LeetCode question left from last lecture, which is question number 27, as you can see here. So as you may recall, in our last lecture, we talk about the basic operations for arrays, right? So we look at operations such as access an element, change the value for an element, add a new element, and delete an element from the array, right? So I know some of you may feel like, hey, those topics are very fundamental, very easy. We have learned that from our lower division programming classes, which is probably true, right? But as you can see, well, actually, after you understand and you grasp those basic operations, you can go ahead and go to LeetCode and solve some technical interview questions, right? So not all the technical interview questions are so complicated or so challenging, right? There are some that actually will test your understanding on those basic operations. That's the reason why in the first lecture, I decided to, well, we can call it explain or review, right? Those basic operations hopefully can lay a foundation for everybody to tackle, complex interview questions. Okay, so now let's look at this real interview question on LeetCode. Question number 27 is called remove elements, right? So I hope you have spent some time after the first lecture, you try this question by yourself. So here, I'm not going to give you some time, so let you try first. So since we have a lot to cover today, we will just look at the solution. So what I want to show you through this coding question is that actually when you write programs to solve the questions in interviews, as you will see, there are often some tiny things that you want to pay attention when you write your code. Otherwise, your code will not be correct, right? So although intuitively you may feel like, hey, I think my solution is right, but the output is not correct. So this coding question will give you a very good example about that, right? So, okay, in this question, we are given an integer array called nums and an integer, we call it a val. So we are asked to remove all occurrence of val in this array in place. In place here means we can't create a new array, right? So one way to solve this problem is like we can create a new array and then as for each element in the given array nums, we check whether the element is equal to val or not, right? If it's not equal to val, we simply copy that element to this new array. We can do that, and the time complexity is actually very good. So, but is not in place, right? It's not in place. So in future lectures, we are going to revisit this coding question, and I'm going to show you a very efficient way or a very efficient approach for solving it. But for now, we will try to come up with a solution which may not be optimal in terms of running time or time complexity, but this can, number one, help you practice the basic operations we learned last time. And the second is usually in technical interviews, it is totally okay or even preferred by some interviewer that you first talk about solutions like this. What I mean is the simple solutions or brute force search based solutions. Those solutions, the time complexity may be very high, but this usually can give you some idea about how we can further improve it, right? So reviewers may prefer to see how you think about a problem and how you can come up with a better solution by observing the simple or naive solutions, right? So that is another reason why I want to share with you the simple solution first, which I'm going to show you in a few minutes, right? Okay, so we can change the order of the elements, and at the end we have to return the number of elements in this array which are not equal to vol, right? So we can see more clarifications here. Consider the number of elements in this array which are not equal to vol is k. So we change this array such that the first k elements contain the elements which are not equal to vol, which is the same as say we remove all the elements or all the elements that are equal to vol, right? And at the end, we need to return k, which is the number of elements that are not equal to vol, right? Okay, so at the end, there's an example. If the input array is this one and the vol is equal to 2, we basically want to remove the 2 occurrence of number 2. So at the end, we should return 4, and there are 4 elements in this array, 0, 1, 3, 0, that are not equal to 2, right? Okay, now I hope everybody is clear about the requirement, and now let's look at the solution, right? So in the last lecture, we have already learned how to remove an element from the array, right? Especially when this element is at the beginning or in the middle of the array. So to solve this problem, we can see that what we need to do is we can loop over the entire array. So basically we check, we loop over all the elements, right? And as for each element, we check if it is equal to vol or not, right? If it is equal to vol, and we can perform the operation to remove this element from the array. Okay, so as you may recall, in the last lecture, we know if we want to remove an element from the array, and when this element is at the beginning or in the middle of the array, we often need a loop, right? Because we will have to move the elements after this removed element 1 slot to the left. So we will need a loop here, because we will also have to loop over all the elements in this array and find out whether an element is equal to vol or not. So we will need 2 loops, or we call them nested loops, right? So the outer loop, we iterate over each element in the array and check if it is equal to vol or not. And if it is equal to vol, then we use another loop, which is the inner loop, to remove this element. And we have to also shift all the following elements 1 slot to the left. Okay, so we will need to use nested loops to solve this problem. So I'm going to use this example given in the problem description when I show you the solution code. First, let's write a loop to iterate over all the elements in this array, right? So here I use a for loop. If you want, you can use a while loop. It's the same. The intuition here is that we will have to iterate over all the elements in this array. So many students will write a for loop like this, right? So for I is equal to 0, and I smaller than num's length and I plus plus, right? A very common for loop that we can iterate over all the elements in this array. And then as for each element, right? So we have to compare whether it is equal to val or not. So when it is equal to val, we need to perform the operation. So we have to remove this element. We have already learned that from our last lecture. So here, okay, so if we run this demo, we run the example. So the first element 0 is not equal to val. So we move to the second element. 1 is not equal to val. Here, val is equal to 2. So 1 is not equal to 2. So we move to the next element. Now, this element is equal to val. So we will have to run the code inside this if statement so we can remove this element. Right? Now, in the last lecture, we have learned that when deleting an element at the beginning or middle of the array, we need to move all elements after this element one slot to the left. And we have also seen the code for doing this, right? So here, I simply copy and paste the code from the last lecture, as you can see, where we create another loop or another pointer, right? I call it j, and I use another while loop. So we could shift or move all the following elements one slot to the left. Okay, we have seen this code in our last lecture. All right, so then if we run the example, we run the demo. So we first move 2 to the left slot, and then 3, and then 0. Okay, and then we are done for removing the first occurrence of 2 in this array. Okay, all right. So okay, now when we are done for this iteration, right, which means actually we finish this while loop here inside this if statement, right? We finish this one, and then the next statement we are going to execute in our program gonna be I++, right? I++. Okay, now I want to draw your attention on the position of the pointer I here, where I now points to the third position in this array before we run I++. Okay, then I hope you can see there is a problem. What is a problem? The problem is the next statement I++ will move our pointer I to the next slot, which is here, which is here. Let me get my pen here. Right. However, we can't do that, or I can't be moved because the next element is this one, right? This element was moved from this position to this position. So now it becomes the current element that we need to check, right? So if we run I++, then the pointer I will be moved to the next slot, and then this element will be skipped, which of course is not right. Okay, so if you write program like this one, you submit to LeetCode, you will see error message. That is the first place where students will make mistake, even for this very simple solution. Okay, now if you understand this one, then how can we solve the problem? How can we address it? Now, so what we can do is every time after we remove an element from this array, right, which means this if statement is true, and then we run everything inside the if statement. Every time when we remove the element from the array, at the end, we run this one, I minus minus. This will cancel this I++, right? So make sure that the pointer I will stay at the current position. So then we can check the next element, right? Okay, so this I minus minus is very important. I minus minus is very important. Okay, so we run I minus minus, we run I plus plus, and we check this condition, I is smaller than num's length. Everything is good. So I still points to this position. Now we run the if statement again, but this element is equal to val. So let's remove it, right? Let's remove it. We are going to run the code inside if statement, try to remove this element. Well, it is the same, right? So we remove this element and then we move, we have to shift all the following elements one slot to the left. So first is 3, then is 0. Everything is okay, everything is good. And now, when j points to the end of the array nums, we run this condition, which is j is smaller than num's length. So here we can see that this condition, first of all, is true, right? When j points to the last slot or last position in this array, this condition is true, which means if we run the code like this one, we will have to run nums j minus 1 equals to nums j and j plus plus, which means we will try to shift the last element one slot to the left. Okay, but remember, at this moment, the last element, the last slot is, well, how should I? Okay, I think we should say the last slot is empty, because previously we have already shifted all the elements one slot to the left. Now the last slot is actually empty. Of course, like in the physical memory, there are values. There is a value stored in that slot, but it is not important, right? Because after we remove the first occurrence of value 2 from our array, and we move all the elements one slot to the left, the last element now we can consider it as empty, right? So now this condition, j is smaller than num's length, is not correct, because in this iteration, for pointer j, it doesn't need to go to the end of the array, right? It doesn't, as long as we finish the last element in this array, we are done, right? Okay, so how can we address this problem? How can we address this problem? So what we can do, actually, we also talked about this in the last lecture, is we can create a separate variable to keep track of the current length of the array. So in other words, this variable will keep track of the number of elements in this array. Again, this is different from num's length, right? Num's length is fixed after the array num is created, right? So, but the variable size can be dynamic, right? So it just it tells us the total number of elements in this array. So given so we create a variable size at the beginning. Of course, at the very beginning they are equal, because the given array nums is a full array, right? So they are equal. But then every time when we run the if statement and we remove one element from the array, we update size. So size minus minus, we will keep track of the total number of elements in this array. So then this condition, we can change it to j is smaller than size, right? Which makes sense, because as long as j, pointer j, reach the doesn't have to be the end of the array, but just when pointer j completes the last element in this array, we are good, right? So we are done. We are done. So it should be j smaller than size. J is smaller than size. So j should stop when it reaches the end of the current array. Okay, and now let's look at I, right? Let's look at I. We finish another iteration. Let's look at I. So now I is here, and well, because 0 is not equal to 0 is not equal to val, so we move to the next element, right? And so then we go back to this condition: I is smaller than num's length. And when I points to this slot shown in the demo, I smaller than num's length, which is true, right? Which is true. But by looking at this example, we know at this step, actually, we already finished, right? We are done. The last two slots, don't matter. They are empty, right? They are empty. So I should stop here, but it hasn't reached num length. So if the condition for this for loop is I smaller than num's length, we will continue running the code inside this for loop, and this may give us the wrong output, right? So to address this problem, same idea, right? So I smaller than size. So when the pointer I go to the end of the current array, right? When I iterate over all the elements, we could stop. It doesn't have to be the end of the array, the end of the original array. So as long as pointer I iterate over all the elements, we could stop. So I smaller than size. No, I smaller than size. Okay, so this is the correct code for this question number 27. Of course, because the problem requires us to return the number of elements that are not equal to val at the end. So as you can see at the end, I add another line of code, return size, right? Because after we iterate over all the elements and remove the occurrence of the value of val, and then the size of the resulted array is the same as the number of elements that are not equal to val, right? So we simply return size. Okay, we simply return size. All right, so let me see. Yeah, we don't have time to run this program in LeetCode, but after class, if you want, you can copy and paste and run it, test it. The last thing I want to mention about this solution is the worst case time complexity, right? So this solution, the time complexity is big O n squared. Why is that, right? Why is that? One way to think about it is, well, from the last lecture, we know the basic operation for removing an element from the array is big O n, right? When the element is at the beginning or middle of the array, it is big O n, right? And now we have another loop where we iterate over all the elements in this array. So nested loops and big O n squared. But a more rigorous explanation gonna be, well, what is the worst case, right? The worst case is gonna be all the elements in this array are equal to val, and then what's gonna happen is, right? So we first remove the first element, which means that all the rest of the elements will have to be moved one slot to the left, right? And the complexity is gonna be big O n minus 1 when there are a total of n elements, right? We remove one element, we have to move all the following n minus elements, and then we have to move we remove the second element, and then all the following elements going to be moved to the left, which is all big O n minus 2, and then big O n minus 3, so on and so forth, go to big O n. Big O 1. We add everything together, right? This will be big O n squared. Okay. Yeah. Well, as I mentioned at the beginning, this is not the optimal solution. This is not the optimal solution. But I still want to share this with you so you can practice. And I'm going to show you the optimal solution in future classes. We will come back and visit this problem again. All right. So I hope through this example, it can help you understand those basic operations. So before we move to the new topic, does anyone have any question about this solution here? Feel free to let me know. All right. If not, I'm going to we'll go to today's topic. I just drop a link in the chat, and you can, by clicking on that, you can see my presentation slides if you want to read it while I present. Okay, so today we are going to look at the algorithm topic called two pointers. In fact, the lead code problem we just saw, the remove elements problem, we use two pointers, right? So remember I and j, right? So pointer I iterate over all the elements, and pointer j help us move elements one slot to the left. So two pointers. In fact, in many technical interview questions about arrays, we use two pointers. And there are different ways for using them. So in this lecture, I'm going to show you a few simple examples about how to use two pointers. And so we will look at three problems on LeetCode. And in future lectures, I'm going to show you a few more technique about using two pointers, such as sliding window and binary search algorithms. Okay. Okay. So now let's look at the first question here. LeetCode question number 344 is called reverse strings. A very simple problem. So want you to write a function that reverse a string. The input string is given as an array of characters. You must do this by modifying the input array in place with big O1 extra memory. Again, we cannot create a new array. We must do that by directly modifying the input array. Example, input array is HELLO, the output array is OLLEH, right? Okay, so now I want you to go to LeetCode. Well, you can just click on the link here. You can go and see this problem. I'm going to give you guys maybe 5 minutes. So I want you to try this one first and see if you can write the code by yourself or not. When you finish, feel free to drop a message in the chat and let me know. Okay, right. So now you can do it now. there anybody who has solved this problem? Okay, let's stop here. And next, I would like to share with you the solution code with a demo. So we are asked to reverse a string. And here, the given string is an array of characters. Right? So the intuitive idea are going to be, okay, so we simply just swap, right? We swap the first and the last elements in this array, and then we swap the next two elements in the array, and so on and so forth, right? So it's like we have, we go from the beginning of the array towards the middle, and we go from the end of the array towards the middle, right? And then we just swap we swap two elements at a time, and until like we end up, at the middle of this array, something like that, right? So for doing that, I hope you can see we need 2 pointers, right? One goes from left to right, right? So one begin from the first element and then go from left to right. And the other one start from the last element and then goes from right to left. Right? So of course we can call them left pointer, right pointer. I prefer to do that, but if you don't like it, well, at least we need 2 pointers, right? And then we simply just swap the 2 elements at the left pointer and the right pointer. So here is an example demo, right? So at the very beginning, the left pointer here points to the first element, the right pointer here points to the last element. So when we write code, we can define 2 variables, left and right. Left points to the first element, right points to the last element. Okay, and then we swap them. Right? We swap them. I hope every one of you know the code snip for swapping 2 values, right? We will need another variable for doing that. So here, as you can see, I create another variable called temp, right? So then we simply just assign one value to temp, and then we swap, right? And finally, we assign temp to the other variable or element, simply like this, right? So I believe in lower division programming classes, you wrote program like that for swapping 2 values. Okay, so here, this is how we can do that to swap the 2 values pointed by left and right. Okay, right. Then after that, we will need to move the left pointer to the next element. We move the right pointer to the previous element. So something like this, right? How can we do that? In our code, left plus plus, right minus minus. Okay, and then we swap those 2 elements again. Okay, and we keep doing this. We repeat, which means we need a loop. And we can use while loop. We can use a for loop. I think while loop is easier. Okay, I think a while loop is easier. So I use a while loop here. I use a while loop here. Then what's gonna be the condition for this while loop, right? We want to keep doing this as long as left pointer and the right pointer are not at the middle. Right? What do we mean by they are not at the middle? So when they are in the middle, or they are in the middle, like what is shown here. They will be equal. Right? They will be equal. So while left is smaller than right, we will repeat. We will repeat and swap elements. Right? And when left is equal to right, we could stop. Right? We could stop. So and at the end we return. Right? So this is the solution for question number 345. A very simple one. Very simple one. Okay. But here, as you can see, we need 2 pointers. We need 2 pointers. Does anyone have any question about this one? Okay, if not, let's look at the next one. This is question number 167. To sum input array is sorted. So we are given an array of integers called we call it numbers that is already sorted in non-decreasing order. Here, this array is one index. What do we mean by one index? So in Java, array indices begin from 0. We talked about this in the last lecture, right? So, but here, we want the index to begin from 1. So, which means when we return the index for a given element, right? So, for example, we want to return the index of the first element. Of course, in Java, we know it is 0, but when we return it, we want to return 1. So it's called a one index. In other words, when we return the index of a given element, it should be the index of this element in this array plus 1. We simply just add 1 to the index before we return it. We call it a one index. Okay. So we want to find 2 numbers such that they add up to a specific target number. And so if those 2 numbers denoted as numbers index 1 and numbers index 2, and the sum of those 2 numbers must be equal to target, right? So we want to return the indices of these 2 numbers, index 1, index 2. Again, don't forget to add 1 to them. Don't forget to add 1 to those indexes before we return them, right? So for example, if you find that the first element and the second element in this array, their sum is equal to target, right? So the index of the first element is 0, and the index of the second element is 1 in this array, right? But when we return it, we should return 1 and 2 because we need to add 1 to their indexes. And there is also a guarantee that there is exactly 1 solution. So we don't need to worry about the case when there's no feasible solution. We don't need to worry about the case when there is more than 1 solution. So exactly 1 solution. Exactly 1 solution. This is very important. Okay, so there is an example, right? So if the input array is this one, 1, 2, 5, 6, 9, target is 8, and we know here the 2 elements that satisfy the requirement is this one. No. This one and this one, right? Because 2 plus 6 is equal to 8. This one and this one. And the index for element 2 is 1, right? Because index always begin from 0. This is 1. This is 3, right? So when we return the result, it should be 2 and 4 because we need to add 1 to them. So it's 1 index. So this is 2, this is 4. Okay, so now I want to give you some time. Again, try this one first by yourself. See if you can solve it or not. So the hint I can give you is to solve this problem, we still need 2 pointers. And actually, you can try to create 2 pointers like what we did in the previous problem. So one pointer goes from left to right, one pointer goes from right to left. Okay, and see if you can solve it or not. Okay. So I'm going to give you some time, try it. And we will go through the solution together. Okay, has anyone solved this problem? Oh, there is a question for me in the chat. Yes. So let me drop the link in the chat. So yes, we are now looking at question number 167 on LeetCode. Okay, you can take a look. Yeah, great. All right, if you haven't finished this one, did you have some idea about how to do it? Or, it's like, I know how to solve this problem. I just need more time. Or it's like, I don't have any clue. I'm still trying. Okay, we'll look at this one together, all right? So, well, one simple solution will be, well, we use 2 pointers, right? But one pointer loop all the elements from left to right, and then in each iteration, the other pointer just loop over the rest of the elements. So this is like brute force solution, right? We just simply try all the possible pairs of elements and see if their sum is equal to the given target or not, right? So we will need 2 loops, a nested or a nested loop for doing that, right? And then the time complexity is going to be big O n squared. You probably have solved similar problems back in our lower division programming classes, right? But here, there is a better solution. There is a better solution. So what is really important here in the problem description is this array is already sorted. This array is already sorted. So there is a better solution. So we will still use 2 pointers, but let's try left pointer and right pointer. So we are going to create a pointer that goes from left to right, and the other pointer that goes from right to left, like I show you here, right? So to do that, we can, we create 2 variables, left and right. It's the same as what we did in the previous problem. So, and here the question we will have to answer is, well, after we create those 2 pointers, how can we, or how shall we move those 2 pointers? How and when, right? How and when shall we move those 2 pointers? Okay, so let's look at this demo here. At the very beginning, left pointer refers to the first element, which is 1. Right pointer refers to the last element, which is 9. Of course, like we probably want to see if their sum is equal to target or not, because if that's the case, we are done, right? But unfortunately, 1 plus 9 is not equal to 8. It's bigger than 8. When it is not equal to 8, what should be the next step here? Okay, because this array is already sorted, and because there is only one, there is exactly one solution, which is mentioned in the problem description, right? So when we find 2 elements, their sum is larger than target, what shall we do? Of course, we want to decrease their sum, right? Because it's too big. How can we do that? Okay, now in this case, we can see if we can't move the left pointer to the right, because if we do that, this will increase the sum, right? So what we could do here, in fact, is our only option is we move the left pointer to the, we move the right pointer to the left. So in this way, we can decrease the sum, right? And hopefully we are able to make it equal to target. Agree? So we have some code like this, right? If their sum is larger than target, we should move the right pointer to the left by decreasing it. So we can reduce the sum. So right minus minus. Okay, now in this demo, we can see now the right pointer refers to 6. Okay, this time 1 plus 6 is 7. But unfortunately, it is still not equal to 8. In fact, it is now smaller than 8. Right? When the sum is smaller than 8, what shall we do? Now, similarly, we will want to increase the sum, right? How can we do that? We need to move the left pointer to the right. So when the sum is smaller than target, we should move the left pointer to the right. So left plus plus. So we can increase sum. We can increase sum. Okay, of course now in this demo, in this example, now we find that, well, after we move the left pointer to the right, now 2 plus 6 is equal to 8. And we find the two elements, which is good. So when their sum is equal to target, we could stop, right? We could stop. And by returning their indexes, and again, don't forget to add 1 to their indexes. So left plus 1, right plus 1 should be the result we return. Now, of course, in other examples, we may not be able to find these two elements so quickly. So we probably have to move either the left element, the left pointer, or the right pointer for multiple times. So what we can do here is we can have a while loop for doing that, right? And again, just like in the first problem we saw, and the condition could be left is smaller than right. So the left pointer and the right pointer, they moves towards the middle. And some of you may wonder, well, can we, well, in this case, can we guarantee that we can find the solution? Because when we move these two pointers, this is not actually brute force, right? We don't examine or check all the possible pairs of elements. So, but no worries. The answer is yes, because there exists exactly one solution, and by doing this, we will be able to find it. Right? So if you think about the logic, we can't miss it. We will be able to find it. So this will be the solution for this question. And as you can see, we still use 2 pointers, left pointer and the right pointer. And so you can think about the time complexity of this approach, right? And I hope you can figure out that the time complexity is big O n, right? And so the worst case is going to be when left and the right, they are kind of like, at the middle or the center of this array, right? So which means the left pointer travel almost half of the array, and the right pointer travel half of the array, and then they kind of like finally meet at the center. So this time complexity is about big O n, because we in fact loop over almost all the elements in this array, right? So big O n is a time complexity. Okay, does anyone have any question about this problem and the solution code? Okay, if not, um, yeah, let me another lead code question that is very similar to this one is question number 977. It's called squares of a sorted array. So we don't have time to go through this question here, but you can try this one after the class. Again, you can use left pointer and the right pointer to solve the problem. So left, right pointers, similar to what I show you in the previous two problems solutions. So once I build the course website for our program, and I'm going to write a solution onto the course webpage. And so then I'm going to add everybody there. You can find my solution on our website. So, but I encourage you to first try that by yourself. Okay. Okay, now we come to the last question or the last lead code problem for today's lecture. Question number 88 is called merge sorted array. Merge sorted array. So we are given two integer arrays, nums1, nums2, sorted in non-decreasing order. So both of them are sorted. This is a very important information. We are given two integers, m and n, representing the number of elements in nums1 and nums2 respectively. So we know the number of elements in those arrays. We are asked to merge nums1 and nums2 into a single array, sorted in non-decreasing order. Now, we want to merge them, make sure the new array is still sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged. The last n elements are set to 0 and should be ignored. Nums2 has a length of n. So basically, nums1 has enough space to hold all the elements in nums1 and nums2, right? So the first m elements in nums1, they are real elements. And then there are also n positions or n slots that are empty that we can use to hold other values, right? So it's good enough to hold the merged array. And come up with an algorithm that runs in big O m plus n time, which is linear time. Okay, now here is one example. If the first array is 1, 2, 3, 0, 0, 0, m is equal to 3. So here 1, 2, 3 are the elements, and the last three positions, they are empty available space. Nums2, 1, 5, 6. N is equal to 3, 3 elements. Of course, the merged array is going to be 1, 1, 2, 3, 5, 6, right? So, it's still like in non-decreasing order. All right. Okay. Now, I want to give you some time and let you try this one first. And this one is more complex as compared to the previous two questions. So try it first, and then I'm going to show you two solutions. The first one is based on the basic operations we covered in the last time, and the second one is a better one, but there's a place I want to draw your attention, because many students will make mistakes when solve this problem. But again, I want you to first try this one by yourself, and I'm going to give you some time. This time I'm going to give you a little bit longer time. Let's say maybe 8 minutes. Let's see, and then we will go through the solutions together. Okay. Let's stop here and let's go through the solution together here. Okay. So we are given two arrays and we want to merge them into one array. And because well, when we merge these two arrays, intuitively we will have to loop over every element in each of these two arrays, right? Because we have to compare the elements and see which one is larger, which one is smaller. So when we merge them, we can ensure that the new array or the resulted array is also sorted, right? Which means we will need at least 2 pointers. So one pointer loop over one array, right? So we can loop over all the elements and compare them. And well, many students, when try to solve this problem, they set up these 2 pointers. Both of them goes from left to right, right? Which is okay, and we can still solve the problem. So as you can see, I have an example here with this approach where we have 2 pointers from left to right. So I use I and j here, right? I and j, both of them goes from left to right. So let's see what's going to happen here, right? So with I first points to the first element in nums1, j points to the first element in nums2. We compare these two elements, and 1 is smaller than 2, right? So we could move pointer I to the next element, right? And now I points to the element which is equal to 5, and because 5 is larger than 2, so we have to insert 2 into nums1. Okay, right? And we have learned this operation, which is a basic operation from the previous lecture. Right? This is like we want to insert a new element into this array at the beginning or the middle. And we know this will evolve like moving the rest of the elements one slot to the right. So we can move, so we can make space for this new element, right? You remember that? So what we need to do here is, well, in order to insert 2 into the first array, right? We have to move elements to the right like this, before we can insert 2 into the first array. And you know the complexity for doing this basic operation is big O n, and we talked about this last time, right? So, well, now we are not done yet, right? So, like we will just we will continue, and in the worst case, right? In the worst case, all the elements in the second array are smaller than the elements in the first array, which means we will have to insert all the elements in the second array into the first array. And as you can imagine, the time complexity is going to be big O m times n, right? Because every time we'll have to move all the elements in the first array one slot to the right before we insert one element from the second array. There are n elements in the second array, so it's going to be m times n. Right? Okay. This approach, as you can see, is not very efficient. In fact, in the problem description, it asks us to find a solution. Time complexity is big O m plus n, if you remember, right? So, well, this approach can solve the problem, but it's not the optimal solution. Okay. All right, and now how can we solve this problem in a more efficient way? The idea here is, instead of moving these 2 pointers from the beginning to the end, let's try the opposite. It's like let's move the 2 pointers from right to left, Okay, and as you will as you will see, the good thing about this approach is we don't have to, we don't have to move elements one slot to the right. Okay, so we set up 2 pointers, I and j. Both of them points to the last element in these 2 arrays. And then we compare them, we merge them. Let's look at one demo. So, well, first of all, we create these 2 pointers, I and j, and we, create them. They first point to the last element in these 2 arrays, right? m-1, n-1. Okay, and so now I points to 6 and j points to 4. So 4 is smaller than. So 4 is larger. Sorry, 6 is larger than 4, right? 6 is larger than 4. So we know 6 is in fact the largest element because nums 1, nums 2 are sorted, right? So we know like actually we should place 6 to the very end of the array, of the first array. So in this case, we should place 6 to the very end of the first array, right? And as you can imagine, right? Afterwards, right, we may have to place other elements towards the end of the first array as well, similar to this step. So we will need another pointer so we can keep track of the location for storing those larger elements. Right? So here I create the third pointer, which is called k. Well, at the very beginning, k points to the last slot or last position in the first array, nums 1. So k is equal to m plus n minus 1. Right? And so we compare the elements pointed by I and pointed by j. The larger elements will go to the position pointed by k. So if nums 1i larger than nums 1j, nums 1k will take the value of nums 1i. So the larger element will go to the position pointed by k. Okay, and so after this step, I should move to the previous element, and the k should also move 1 slot to the left, which is here. And so we know we can say I minus minus, k minus minus, right? Okay, and then we compare 5 pointed by I and 4 pointed by j. And the 5 is larger than 4. So we know now we should put 5 or place 5 to the position pointed by j, which is also towards the end of this first array. Okay, something like this, right? Okay, and after that, both I and j should move 1 slot to the left. All right. Okay, now this time I points to 1, j points to 4. Now 4 is larger than 1. Now I believe you know what we need to do next, which is we need to copy 4 to the position pointed by k, something like this. So we have an else branch here. We simply copy the element pointed by j to the position pointed by k. And after that, pointer j should move to the left. K should also move to the left. Something like this. So we have j minus minus, k minus minus. Okay, now we repeat this process, right? We repeat this process, and so now I points to 1, j points to 3. So 3 is larger than 1, so we copy 3 to the position at k. And then we move j and k 1 slot to the left. And we keep doing this. Okay. And then when should we stop, right? When should we stop? Now, in this demo, we can see when j is smaller than 0, the loop should terminate, right? Because when j is smaller than 0, which means we have already copied all the elements from nums2 to nums1. So of course we should stop, right? And then there may be another case where j becomes smaller than 0 first. In that case, we probably also should stop, right? So we can have a condition here: I larger than or equal to 0 and j larger than or equal to 0 for this while loop, meaning that, well, as long as there are still elements in nums1 and nums1 and nums2 that we haven't compared, we should repeat, right? We compare them, we move them, okay? And so finally, nums1 is the resulted merged array, right? Is the resulted merged sorted array. So we have a code like this. Okay, and but one thing I want to draw your attention is that, in fact, this code has a bug or has a problem. Now, what is a problem? So in this demo, we can see I becomes smaller than 0 first. What if, j, pointer j, j becomes smaller than 0 first. But what if I becomes smaller than 0 first? Let's see another example. This is an example, and we run the code. Again, we first compare the elements pointed by I and j, and then we place the larger one to k. So like this, and then this we compare 2 and 5, so it should be 5, right? And then 4 and 2, it should be 4, and then 3 and 2, it should be 3, right? Okay, now I is smaller than 0. Now, when I is smaller than 0, the while loop terminates. Right? The while loop terminates. However, if you look at nums1 here, we are not done yet, because there are still 2 elements in nums2 that haven't been merged into nums1, which is 1 and 2, right? 1 and 2. 3, 4, 5, 6, they are all good, but 1 and 2 haven't been merged into nums1. So we have to add one extra step here. So we copy all the remaining elements in nums2 to nums1. Okay, 1 and 2. How can we do that? We can have another for loop. Basically, we begin from pointer j, and we go all the way to the first element in nums2, and we just copy them to the corresponding position at nums1. And then we are done. Of course, when j becomes smaller than 0 first, and this condition, x is larger than or equal to 0, will be false. So this for loop will not be executed. That's still good. That's still good. Now, this is the place where I want to draw your attention when you write your code for this one, because this is like a mistake many students may make when solving this problem. Of course, there will be other solutions to this problem, and this is only one solution I want to share with you. All right. Is there any question about this LeetCode problem? All right. If not, then this is all for this lecture. And just want to remind you, I encourage you to, after class, practice those problems again, and make sure you understand them, and make sure you are able to solve them without referring to the lecture notes, because in the real technical interview, you don't have any reference, right? So like make sure you understand them, and just practice a few more times, and make sure you can solve them by yourself. You understand And in our next lecture, we are going to continue this topic called 2 pointers. I'm going to show you the slow fast pointer, and we will also look at a few LeetCode problems together. Well, I will see you guys next week. Have a good one. Thank you. Bye bye.